Continuing from where we were last discussing constraints and parenting everything, we have this example here to walk through and go through. This is what I provide for my class, but you can just kind of take a look and go through this with me here. And essentially, the challenge is to make sure that the Ferris wheel is grouped properly, will spin and rotate properly, and that everything, all the seats, will rotate with it. So you can see here, if I select the group 2 in the outliner, it contains the rings, the main body, the rings 2, both the sides of the rings, and then the axle in the middle. And essentially, when I select that group and go to rotate, it's the pivot's in the wrong location. Now, thankfully, this is a pretty easy fix since this is just a cylinder and circle object, right? We can just center the pivot, which is this button right here, on our poly modeling shelf. Or if you don't like to use that button, you go to Modify, Center Pivot. If I can find it, there it is. And this will allow us, to spin specifically along the Z-axis, right? And so now we don't have like any weird wobble. It's not offset or anything. Additionally, we could have manually moved the pivot, but I don't really recommend that for this one, but let's talk about it. In case your object isn't perfectly cylindrical or anything, here's how you would move that. So I can tap D as a delta on my keyboard. I can now move this pivot to wherever I would like, and it's going to pivot from that location now instead. D again to move once more. And now I can pivot from that location. If I ever want to snap this specifically to a location using vertices, we can easily do that. I can hold V as in Virginia or vertex on my keyboard and move to snap. And what's going to do is going to move this pivot point to any particular vertex that I'm hovering my cursor over. And if I snap it to the very tip of this cylinder here, that's going to be the center of this object and is very easily going to allow us to rotate, pretty much like centering the pivot. If you look at it from the front view though, it's not centered in the middle here. So I'm going to tap D again, and I can hold V as in Virginia on my keyboard to push that to the center here. And again, whenever I do this, I'm holding V and then I'm moving on one particular axis. And some people like to just try to push it to one or the other. Like you're trying to push the manipulator. In reality, the manipulator is snapping to wherever my cursor is going. So you can see my cursor goes over a vertex or goes close to a vertex and my manipulator moves there. So your cursor is what you're pushing and what the manipulator is snapping to. And you're not pushing the manipulator. You're pushing it here whenever we're free moving it. But by snapping into anything, we are moving it to whatever my cursor is hovered over. But in the middle here, you can see that very clear example. It's going to go to whatever vertex that I'm snapping. But again, luckily, we don't have to do that for this one. We can just say center pivot and move about our day. Now, obviously, you can probably see the issue here is like as I spin the Ferris wheel, none of the seats go. And if we do direct parents, where I take all the children and I parent them to the group, and we go to rotate this, we spill people out onto the ground, and that's not good. So we need to build some sort of system here for us to maintain the orientation of each individual chair, and then also still spin and move with the object. There's a couple of different ways to do that. Let's talk about way 1. It's a little bit more complex than way 2, but it also introduces locators, and I'm a huge fan of locators. So if we go up here to create, let's say locator, we have a locator that we can move around. What this is a vertex in a position, right? An orientation in place of a translate XYZ location. We also can give rotate values and scale values. But if I was to hit render, we would never see this. This is a null object if you're familiar with After Effects terms, and if you're not, this is just a blank recording of a translate, rotate, or scale that we can use for our benefit. What I want to do with this locator is match it, and I want to create one each for each chair. So I'm going to take this locator, I'm going to match it to the chair here. If we select the chair and we go to rotate it, you can see it pivots perfectly off of the rail system that it's attached to on the Ferris wheel. And I need this to match. I don't want to eyeball this, right? I don't want to just be like, oh yeah, that's good enough, because then it's going to be ever so slightly off. Additionally, if I go to snap to vertex, that would work on a technical level, but we can just make our lives a little bit easier by using some other tools. Because instead of having to snap through multiple views, I could just use something easy. So what I'm going to do is select the locator, add to that selection the chair. So I'm telling the locator to match the chair. And what we're going to do is go to modify, match transformations. In this menu, we have a lot of options. We can say match all, translate, rotate, scale. So we can specifically pick any of the 3 attributes, or we can say match all transformations. Notice there's a match pivots. So if I wanted to move pivots, we can. Not right now. Currently, I'm just going to say match translation. And it pops that locator to be the exact same pivot and location as this chair, which is really, really nice. Cool. So really quickly, I'm going to go around and do that for each of these. I'll pause so you don't have to watch me do that. I'm on the last one. I just thought I would unpause to show the steps here. So I'm just going to duplicate it. So Control D, I can slightly move it so I know where it's at. And then again, just to repeat, just because I like repetition, select the locator to the chair and then say modify, match transformations. And specifically, I want to do translation. Cool. So I've got all of my locators set, but none of them are parented or constrained to anything, so that they have the same problem as the chairs. What's really nice with these locators is that I can now parent them into group 2. And the way I'm doing that is I'm selecting them all in the outliner, middle mouse clicking and dragging to group 2. Alternatively, I could just select them all and then add to that selection group 2 by holding Control on the outliner and clicking group 2 and hitting P on the keyboard, because it'll do a direct parent. The problem is they also still maintain the rotation values. That's okay, no worries. Because what this allows, and if you recall back to what we talked about last time, is this gives us a vertex, a point in place, parented under something. So it's going to be given its parents' attributes, translates, rotates, and scales onto each of these locators. But then each of these locators also have a translate X and Y telling it where to be. What that equates to is as we spin, we have a translate position for each of those areas of the rail. And we can now build a constraint to our chairs. Now, hopefully you're already thinking of which constraint it is, but I'm going to say, hey, parent, constrain 9 child. So select the locator and then the actual chair. We're going to go to constrain. We'll pop off this window. We can pop off these windows, by the way, by just clicking that top bar. It'll tear off a little extra thing that'll just constantly stay up. We're going to use a point constraint at first, and this is going to be the proper option for us. And we're going to make sure maintain offset is checked on. So I hit apply. And now when I go to this group and I go to rotate it, you can see that one chair that I have done still maintains forward and doesn't spill anybody out, which is really, really, really nice. And that's what we want. So I can start going around now and doing this to all of these. So again, it is locator, because this is the point value in time, and point constraints only come across to translates. And I'm going to add to that selection the chair. Apply. I go to select the group and rotate it just to check my work. It is rotating. I'll hit undo to get that back to 0. I'll pause the video, go through and do the rest. All right, so now we have all of our rotates properly set. So we're no longer spilling people out onto the concrete, and instead they could travel just fine. So what I'm going to do is I'm going to undo all of what I just did, and I'm going to show you another way we can get the same result. And I don't have to undo enough to also just like get rid of the locators I created. I could just select those and either hide them or delete them. Right now I'm just going to hide them because there's another way we could achieve this. I'm going to close the point constraint window, options window. I'm going to open up the parent constraint options window. And if we were to build a direct relationship between the parent, which is the group, and the child, which is the chair, and apply that, whenever I go to rotate the group, it's still going to spill people out onto the ground. There's something else we could do here where In this parent constraint window, let's see if I can zoom in here real quick. In this parent constraint window, we have these options to check on translate, rotate, or to specifically check on only the particular axis. I will say this does sometimes introduce some issues if we start specifically going on each individual axis, but we will use this often, especially later in the course. So what I want to do is I've got my chair 1. I'm going to select my group 2 and go to my chair 1, right? So parent, then child. And I'm going to uncheck rotate and hit apply. And let's take a look at what that does. It's the same result, right, as we would get if we did not take these locators. Or if we, let me rephrase. It's the same result as if we did these locators for each of these. So I can start going around to each of these groups and children and hitting apply. A really quick and easy way to do this, if you have to do a lot of these, and this is what I do when I pause the video, and I won't do it this time, is I'm selecting the group, then the child, and hitting apply on the parent constraint window here, right? But very specifically, if I have to do that a lot, what I can do then is for the next one, I can select the group, which is the parent, then the child, and G on the keyboard is your recently, like it's your last use tool. So essentially I could just use that button instead, and it's going to apply the parent constraint multiple times. So now when I go to select the group, again, we have the same result. Oops, missed a chair. There we go. And obviously, if you were to rotate off the axis and break the Ferris wheel, you know, things look bad, but luckily for us, this is all that I'm looking for. All right, let's move forward. Okay, now what we have is the Stella project. What this allows us to do is to utilize constraints and utilize multiple constraints to toggle between specifically. We're going to walk the dog across the path using Frogger rules, right? So instead of dodging cars, we're going across lily pads or whatever you want to call these blocks, right? So what I want to do is get Stella onto the blue, then the purple, then the tan, then the green, then the red, and then over here to our target. And to do this today, what we're going to use are point constraints. So in my constraint menu here, I'm going to go to point option box. So I have this opened. Let's first demonstrate what maintain offset is and how we can use it to our advantage. So in this moment right now, I need Stella to be here at home base. And we're gonna go from home to this first blue cube here. We'll give it a little bit of time here. We'll go forward right there. We'll go to this one, just the way, you know, we got a little animation at first and then we start booking forward. If I say, and we want Stella to move with this cube and be on it, right? So if I say, hey, parent, constrain your child, and hit apply, Stella moves, but Stella is maintaining that offset that she initially had from the cube. So she's going to always maintain that offset with this particular constraint. I want to undo that. In my point constraint options here, I'm going to uncheck maintain offset. And now when I hit apply, Stella pops to this cube. Why is that? We are no longer maintaining the offset. And if you take a look at the cube and the pivot point, what's happening is Stella's pivot point is moving specifically to that cube to match. So essentially we're doing what we just talked about previously with the locators. We're doing a match transform, but we're no longer maintaining the offset. And this is really nice for moments like this, where we want to build constraints from one object touching another. So now wherever I move, Stella moves on that cube. The whole point of this little project is to showcase that we can have multiple constraints on an object. So I'm going to go to another point in time. I'll say right here, where I want Stella to jump from this blue cube to the purple cube in front of her. So I'll say parent, then child, and hit apply on my point constraints. If I scrub through this, Stella's just sliding all over the place. The reason being is we have two constraints and it's averaging the distance between them. To see that, there's a couple different ways. First and foremost, let's select Stella, and in the channel box, note under shapes, right? We now have this point constraint 1. Under this, we have a lot of things like node state, offsets, but then we also have row 1 and row 2. These are the names, if you take a look, these are the names of the cubes that we're bouncing between. So row 1 are all the blues, row 2 are all of the purples, tans are row 3, and so forth. Let's go back to that constraint over here in the channel box. So row 1, 5, so it's the 5th cube on row 1, right? W0, weight 0, weight 1. So row 2, 11, weight 1, weight 0. What we're seeing here is Maya is making a list starting with 0. It's not 1. I know it's annoying, but we're starting with 0 of the first one that we have and the second one that we have, which is W1. 1 means that this constraint is turned on. 0 means that this constraint is turned off. So if I zoom back out and then I set that row 1, 5, W0, if I set that weight to 0, we've now toggled row 1 off and row 2 is on. It's still on. So now Stella's going from row 1 to row 2. So what I want to do is scrub forward in time, and I'll find another moment where we line up to hop to that cube. And I'll say, okay, cool. Parent, constrain your child. Point constraint. Maintain offsets off. Hit apply. We're still getting an average of those two. So what do I need to do is I now need to go back over here to my point constraints under Stella. I need to turn row 2 off. And row 3, this new one that got added, weight 2, right? Technically weight 3, but whatever, is set to 1. So when I zoom back out, we're out following the brown cube. I'm going to keep doing this. Go to the green here. We'll go to the middle green here. About to run into a problem. So what I do is take Stella to the green cube, hit apply. Just like I had before, right? Green cube, then Stella. Sorry, I had that order backwards. Yeah. Parent, then the child. Apply. Stella's awkwardly sliding. I will go over here, make sure to turn row 3, which is the tan row, off. And row 4 is on. Ah, geez. Right? Stella's not on the cube. So if you take a look, this row is purposely got mix matched pivot points to their objects. And what that does is it's going to throw Stella off. It's going to match it up to that pivot point based off the translates and rotates everything, right? So I'm going to undo. And this is an important part of this little mini exercise. You want to make sure to clean up your objects. You want to make sure your scene is set up nicely before you start doing any work to it. And in this moment, what that means is checking out this green cube, seeing that it has translate X's and scales. Additionally, seeing that its pivot point is not lined up. So we'll freeze transforms like we've talked about before. I'll go ahead and delete history, and I'll center pivot. And I want to note that centering the pivot is actually wrong here, because you can see here on the tan platform, Stella's feet are on top. But now if I go to select the row 4 and then Stella and say point constraint and go back here and turn row 3 off, Stella's feet starts to intersect the bottom. So I want to undo that. This is where what I was talking about earlier, where manually moving the pivot comes into play. Because if we take a look at the pivot, it's in the middle of this cube, right? Because we centered the pivot, it looks at all of the vertices, it centers it based on all of those. But what we could do is snap this pivot using the D key and holding V as in Virginia or vertex. I'm going to do only the translate Y, and I'm going to snap it to the top. You can see if I try to push it up, it kind of works. But more importantly, to demonstrate this, right? Wherever I take my cursor, whatever vertex I hover over, Maya's going to snap that pivot specifically to that vertex. So now if I select box, hit Stella, apply, turn the previous row off, we are now solid. I'll scrub forward a little in time to find a red cube to do the same thing in. So parent, then child, apply. Row 4 off, row 5 on, we're sitting on top of it. Scrub forward and to the target we go. Parent, then child, apply. Row 5 off, and we're on the target. And we have now successfully maneuvered Stella all the way across. What I want to do now is actually showcase how we go and animate her going across using these constraints. If I select them and set them all to 0 and then put Stella at 0, she goes back to her home base. But you'll see as soon as I start scrubbing, she's going to pop to wherever she wants. So on a technical level, I need another constraint for Stella on home base, or we add a keyframe to her. For today, let's continue on the conversations that we've been talking about. So what I want to do is, instead of keyframing Stella, I'm going to set her translates to XYZ 0. I will not move my timeline or anything. I will create a locator. I will then match this locator to Stella's position. So locator selected, selecting Stella and saying modify, match translation. Now I'll give this locator a name. I'll rename it to home base. Had to think of a name. Home base. So what I want to do is also build a point constraint here. So I'll select the home base and Stella and apply a point constraint. So again, if I want to animate all these, if I select Stella and hit S right now, it doesn't, I'm kind of break things. You can see now we have green on the translates, reds on the rotate scales, and then none of our rows, none of these constraints actually got keyframed. And if I start scrubbing, Stella's just broken. We'll talk about that moving forward. So I've undone that keyframe. Instead of putting it directly on Stella, what you'll see over here on the left side of the screen in your outliner is under Stella is a point constraint. This is that node. This is the node containing, zoom back in. This is the node containing all of those constraints that we just talked about. And now when I hit S, instead of keyframing Stella's translate XYZ or rotate or scales, what we're doing is keyframing all of the attributes that we're seeing here. And really, I'm not worried about node state, offset XYZ. I am worried about all of these rows. All right, let's zoom out and take a look. So what I want to do is on frame 20, I'll set a keyframe of making sure home base is turned on. And then I'll go a few frames forward, let's say 25. I will turn on row 1. I'll set that to a value of 1. And home base, I will set to a value of 0. And I'll key that. So now Stella's popping forward. We're not going to worry about this transition animation in the moment, and we'll come back to that with a future assignment. But essentially what we're seeing is, even though I have a transition of 5 frames, where we should see like a slide, it's popping. And the reason is, I'll pull up my graph editor to show you. If you take a look at my graph editor, what I've got is stepped keyframes. And I have that setting specifically for animation. I teach character animation as well. Now, luckily, you don't have to worry about what I'm worrying about, so don't worry about it. I just had to change my default keys back to spline, and we're good. And I'll go ahead and set those to automatic spline. So now, this should be kind of what you're getting. If you know how to change your keys from step to spline, you're more than welcome to do that in your graph editor, however you'd like, or linear. For today's this little example of Stella here, it doesn't really matter. I'll hop back to general. We don't need the graph editor. Cool. So we've moved Stella up. And if I wanted this to happen at a later time to be more aligned with where Stella starts at home base, I can just shift these keyframes on that constraint to happen later. There we go. So now let's continue this forward. Point constraint, I'll go to, I think it was this one, but I can't recall. We can always shift these around. I'll set the keyframe at 106. I'll push forward to like 110 and change from row 0, toggle off, and row 2, toggle on. And we'll set a keyframe. Now Stella's way off base, so I was very wrong on which of the purple boxes that she went to. And again, all I need to do is I can either undo and get rid of those previous keys or just shift these to happen later. There we go. I do have some odd sliding here happening, and I can see that I've just made a mistake as I set my keyframes. And I think more importantly, it's just what I was doing in the graph editor. So let's pull that back open. If you have the same, essentially what's happening, you can see it here in any one of these. It's overshooting in the graph editor because we're set to spline or whatever. So I'm going to set these to linear. And if you run into that issue as well, and you want to fix it, what we could do is open our settings. So a little orange guy in the bottom right corner running from gear. Go to animation. And instead of default in, default out spline, let's just set these to linear and hit save. And for this particular purpose, that'll work well for us. So I'm going to push these keys to be a little bit later, but then again, that's just a visual, nothing really super important today. Maybe just a hair sooner. Maybe yeah, there we go. So next thing, I'm moving up to the next box. I'll set a keyframe, go about 5 frames later, turn row 1 off, or row 2 off, sorry. Row 3 on. So now we're popping forward. And I know I go to this green box, so I need to set a keyframe. That way row 3 is still on. Go a few frames forward. We'll make sure to move that keyframe back just a few frames. Go to here, set it. So row 3 off, row 4 on. Keyframe that. And now we got to get Stella onto the red box. I don't remember which one, but we'll find out here shortly. Let's think it's this one. I will say set a keyframe a few frames earlier. And then row 4 will be off. Row 5 will be on. Yep, it was that one. It was a good guess. If you're wrong, you just have to shift your keyframes around. And then going to the target, set a keyframe. A few frames later, row 5 off. And target on. Keyframe. So now if we play the whole thing, we'll see that Stella starts at home base, goes from locator 1 to locator 2, 3, 4. I say locator, but I really mean these platforms. And that's just the idea behind this little practice here. And it's just to practice constraints, understanding that we can match the transformations using maintain offset and unchecking that. Additionally, understanding that, oh, hey, like I can also make sure that I need to clean up my objects, make sure they have a good constraint system set up and pivots, and they're not got any incoming connections. Yeah, cool. But I do believe that's where we'll wrap up for now. Let me make sure and check my notes. Okay, yeah. One last thing is this was the homework I assigned during this time. Obviously, I'm not able to share this online, but for people in my class, this is the expectation, is to just make sure everything is connected and rotated properly, starting with this control, so that it's going to be aiming at everything's going to be rotating, aiming at the right positions, and everything's moving properly. Just to quickly go over a few things here, you want to make sure to just fix it so everything's working. You want to talk about parent constraints. You're going to be using point constraints. You're going to be using orient constraints, aim constraints, which we talked about last class. Making sure that we use maintain offset when we need to. Sometimes we don't want this. And there's, sometimes when it's turned off, it'll make the child match the parent. Using offset groups allow us to control objects inside, allowing them to further be animated or constrained. Really, really important. By the way, offset groups and aim constraints are super crucial for this particular assignment. Locators allow us to create a vector to be aimed at, constrained to, or grouped to. Very, very important. It's kind of either one of these two, to be honest, but regardless, you definitely want to make sure to use those. You'll be freezing transformation because we need to clean up the objects on some of these. So if you select this bar up here, you can see its pivot and everything is really off and the object is moving very oddly. I was editing this video and just wanted to add in here that the axes for these look locked, but very specifically they are not just locked, but they have incoming connections to them, which means that something else is controlling them. We'll talk about this as we move forward, but a functionality that I just wanted to briefly show here before ending this is, you can see here rotate Z has a yellow connection, meaning that it has something incoming telling it what to do. But if you just right click and say break connections, it's going to get rid of that, and we can now animate that or connect that up. And you can see the other one auto updates with it, and that's just a good thing to have. But break connections is a nice important feature. We may circle back to that a bit more later as well. You want to also know how to move pivots, and I remind everybody of how to there. So essentially, you're trying to get this to work based off of what we discussed previously. If you have any comments, questions, or concerns, please let me know. Otherwise, have a fantastic day.